The coefficient of determination, also known as r squared, is the proportion of variance in one variable explained by another. It can range from 0 to 1, and it is simply the square of Pearson r, or what I've symbolized here as rho. So we just square this r value, and that gives us our coefficient of determination. So let's look at an example. All right, so we already have an r value from earlier. This r value, we calculated it here. It's the correlation between sepal length and petal length. And we can very simply square that value, and it will give us the r squared, the coefficient of determination. So what this tells us is that it indicates that 76% of the variance, so remember that term variance, 76% of the variance in iris petal length can be explained by sepal length. So this kind of r squared is even easier to understand in a situation where one variable could more straightforwardly drive variation in the other. So where we can think that there's some causal relationship between one or the other. In this case, we don't really have that kind of causal, obvious relationship between sepal length and petal length, but we can still nevertheless talk about the proportion of the variance in one variable that is explained by the variance in another. And so as a comparison, only 1.4% of the variance in sepal width is explained by sepal length. So we can toss our sepal length and sepal width. Remember, those are not very correlated. So we can throw those two vectors into our Pearson R method, and then we'll pull out the first output, which corresponds to the r value, and we simply square that r. That gives us r squared, and it tells us that, yep, just 1% of the variance in sepal width is related to the variance in sepal length. Much, much, much less than the variance in petal length associated with variance in sepal length. So I've touched on it already a little bit in this video. We've talked about how just because there's correlation between two things doesn't mean there's causation. Let's dig into that in more detail next.